Well, for over 30 years now, we've been looking at the history of climate as recorded in glaciers around the world. We've now drilled in 16 countries, as well as Antarctica and Greenland, to try to put together the history of climate as it's recorded in ice. In the glaciers around the world, we have a history, annual history. In the upper layers, we can go back 2,000 or 3,000 years looking at the annual, but the ice cores go back much further in time, and we have cores now that go back over 800,000 years, and there's a real effort to try to find ice that's 1.5 million years in age on the planet. In the glaciers around the world, there's a history, and that history is in the snowfall, which becomes dense and becomes ice, and we can look at the proxies for the climate of the past. We can look at temperature, precipitation. We can look at volcanic history of the planet. Anything that's in the atmosphere can get archived in that snow. So they can give us a real long-term perspective on where we are in the 21st century. The thing that is probably most important is what is the long-term temperature history of the tropical ocean. We know in today's world that tropical ocean temperatures are extremely important in driving the climate. Big things like El Niños are driven out of the tropics. Even though our ice core records come from the land and from the highest mountains on Earth, they are really recording what's going on in the oceans. And they do that through evaporation, water vapor that becomes precipitation, snowfall to high elevation, and gets archived. But it's the driver, it comes out of the ocean, and particularly the Pacific Ocean, in the tropics, where we have the greatest volume of water on the planet. It's in this area that the energy that drives the climate system is absorbed. This is where the evaporation takes place that feeds the water vapor, which is the most important greenhouse gas we have on the planet. Oceans are extremely important for determining the climate. They have a huge heat capacity. When you think about water, the amount of energy that it can absorb. And of course, when it evaporates from the tropical oceans, it actually cools the surface of the ocean, but that heat is being taken up in the water vapor, and when it gets to higher elevation where the glaciers are and condensation takes place, you get the release of heat that warms that part of the atmosphere, which is right up where the glaciers are sitting, and they record that history. Well, you can find on the mountaintops the history of sea surface temperatures out in the Pacific Ocean and glaciers. I think happiness is discovering something that no one has ever seen before. And if you go to a place on the planet where no one's ever drilled an ice core, you're almost guaranteed to find something new and exciting, because it's the excitement of science and trying to understand the processes that bring the climate to us today and how those processes changed in the past. Understanding that is the only way we'll ever be able to predict a future climate.